Titration, calculating concentration. Concentration is a measure of how much solute is dissolved in a solution. It's expressed in two different types of units. The first one is moles per decimeter cubed, and the second one is grams per decimeter cubed. And by far the most common of these to be used in chemistry and calculations is moles per decimeter cubed. So what is a decimeter cubed? It's not a unit that you've met before. The decimeter cubed is a scientific term for the quantity of a litre. One decimeter is equal to 10 centimetres. So that means that 1 decimeter cubed is equal to 10 times 10 times 10 centimetres cubed. So 1 decimeter cubed equals 1000 centimetres cubed. So calculating concentration in moles per decimeter cubed, it's a very simple equation that you need to remember, and that is concentration equals the number of moles divided by the volume, but that volume must be in decimeters cubed. The problem is that we tend to talk about volumes being in centimeters cubed because that's what we can measure in the lab. So we get around that by changing this slightly. So we'll now change it to concentration equals moles divided by volume times by 1000. So let's do an example. Calculate the concentration in moles per decimeter cubed. Of a solution containing 0.35 moles in 150 centimeters cubed. So we take our 0.35 and divide it by 150. This fraction here gives us moles in 1 centimetre cubed, and then we multiply that by 1,000 to get the number of moles in 1,000 centimetres cubed, which is a decimetre cubed, and that gives us the answer 2.33 moles per dm cubed. Of course, they could ask these questions the other way around and ask you to concentrate the number of moles of something. So let's have a look at an example of that. How many moles are there? In 170 centimetres cubed of a 0.15 moles per decimetre cubed solution. So there are a couple of things that we need to do here. We need to think about the volume and the decimetres cubed. So we take concentration and divide it by 1,000 and times it by the volume in centimetres cubed. So moles equals concentration divided by 1,000 times by volume. You could abbreviate that to moles equals C times V over 1,000. Let's do our example. So we take our 0.15, divide it by 1,000. Again, this first step gives us moles in 1 centimetre cubed, and times it by our 170 centimetres cubed, which gives us 0.0255 moles. Moving on to something more advanced, here is an example. Calculate the concentration in moles per decimetre cubed of a solution of sodium hydroxide, NaOH, which has 10 grams dissolved in 150 centimetres cubed. So the important things to look at here is we have a mass and we have a formula and we also have a volume. We can't deal with anything to do with concentration until we've dealt with moles. So our first step is to calculate moles from grams. So number of moles equals the mass in grams divided by the relative formula mass, sometimes called MR. So in this case we take our 10 grams divided by 40, which is the RFM of sodium hydroxide, which gives us 0.25 moles. Now we have moles, we can calculate concentration. So we take our 0.25, divide it by the volume it's in, which is 150, and times it by 1,000 to take that to decimetres cubed, and that gives us an answer of 1.67 moles per dm cubed. Concentration in grams per decimeter cubed is even simpler. So we just do concentration equals mass in grams divided by volume in decimeters cubed, or if we have centimeters cubed given to us, we're going to do mass in grams divided by volume in centimeters cubed times by 1,000. So do these next 5 questions and bring them to your next lesson. You'll need to pause the video so that you can copy down the questions and have a go at them, and we'll go through them at the beginning of next lesson.